All right, this video is going to be covering the properties and how to use these properties to solve different problems dealing with trapezoids and kites. First thing let's talk about is trapezoid. The first property it's got is that it's got all the properties of a quadrilateral. So in my previous videos, we've talked about different sorts of quadrilaterals. If we bring this in, a quadrilateral is a four-sided polygon, and its angles add up to 360 degrees. So it has these properties, and we're going to be adding some additional properties to it. One of them is going to be, in addition to that, we're going to have one pair of parallel sides are called the bases. Okay, so you're going to have a pair of parallel sides, one pair, and that's it. And these are called the bases. So I'll put a number 2, saying this goes with property number 2. Number 3 is letting us know that the leg angles are supplementary. So when you take the leg angles and add them together, they will equal 180 degrees. Remembering the supplementary, if we do not remember, we need to make sure we understand it's 180 degrees. Then the fourth one here is giving us this formula. Okay, we use this formula to find either one of the bases or even the median, which median is in the middle. So here we could take a look at, we know that these are going to be parallel. What is also going to end up happening is this median is going to split the two legs. It's going to bisect them. So each leg is going to be cut into two congruent parts. What ends up happening here is we'll have base 1 up here. This is our median. And then we'll have base 2 down here. In reality, it doesn't matter which one is base 1 and base 2, because when we add, it doesn't matter whether we add 3 plus 4 or 4 plus 3. Moving on to the isosceles trapezoid, we're going to have all the properties of a trapezoid, which is going to also include the properties of the quadrilateral. So we're going to have all of these properties right here, but now we're going to also have the second property here listed. Your legs are now congruent. Isosceles triangle, 2 sides are congruent. Isosceles trapezoid, 2 sides are congruent. The third property here is going to be that our diagonals are congruent. So when we draw in our diagonals, okay, look a lot different than we dealt with rectangles and rhombi and whatnot. These diagonals will be congruent. So both of those lines, the segments I drew, are the same exactly. Well, they should be if they were straight. Then the fourth property is now your base angles. So here and here, these are going to be congruent. But you also remember you have 2 bases. So these will be congruent as well. Remember, we still have the property that the leg angles are supplementary. So over here on the right side, these 2 will be supplementary, add to 180, and so will these 2. Okay, let's go ahead and jump into some problems here. So first problem here, we have if HJ is 32. So right here, HJ, we have 32. And LK, way down here, is 60. We want to find MN. So MN is going to be that median there. So we're going to use our median formula from up here, okay, to solve for this. So let's first start off by rewriting that median formula so we have it right in front of us. We have base 1 plus base 2 divided by 2. So let's go ahead and substitute in. Again, it doesn't matter which one's B1 and B2. Not important. Okay, what's important is where that median is. So here we're going to have our median. We'll substitute in base 1, 32, plus base 2 of 60, all over 2. Now, you've got a couple options. You can go ahead and add and then divide by 2, which is generally what I do. You can also, divide one of these by 2. My suggestion, though, is going to be go ahead and add the numerator together. We're going to get 92 divided by 2, leaving us our final answer that our median is going to be 46. Let me fill that in here, too. Okay, so that's just simple, flat out using the formula by plugging it in. The next problem we're going to look at, number 2, we're going to have to work backwards to find one of the bases. So now I'm going to be given one of the medians. So we look here, we have that HJ right here is 18. And we're told that MN, that's the median, is going to be 28. We want to find LK. LK is the other base. So using that same formula that our median is base 1 plus base 2, all divided by 2. This time we're plugging in for M and we're plugging in for one of the bases. Okay, so here if we have, I'm going to call this base 2. You'll see why in a second. And this will be base 1. We have M. M is right here, 28. So we're going to set 28 equal to, The reason I put base 1 down here as our unknown is because I like to have my variable first. Okay? Then we're going to add the other base, 18, all over 2. Now, when we start working backwards on this, the first thing that we need to do is get rid of that denominator. And this, remember, is dividing by 2. So the opposite is going to be to multiply by 2. And what we do to one side, we do to the other. This is going to cancel that out. 28 times 2 is going to give us 56. Okay, so here to here, 56. And all we have left is this B1 plus 18. Okay, because that 2 is gone now. Now all you got to do is subtract the 18. That's it. Working backwards, you multiply by both sides by 2, and then subtract whatever is next to what we're looking for here. Okay, so we subtract these out. We're going to find out that our base, this should say LK. Just now noticing that. Let's go ahead and change that. LK is going to be equal to 38. All right. So number 3, we're going to now use some more properties here, other than just our median formula properties. Here we want to find the measure of angle D. So over here we're going to find the measure of angle D. Well, there are a couple different things that we need to remember here. First of all, we have these congruent marks here. So this means we are dealing with your isosceles trapezoid. So the first thing we're going to look at is that we'll go ahead and go over here to the regular trapezoid. Your leg angles are supplementary. So here we can type in leg angles supplementary. So that means A and C together are going to add to equal 180. So if we take that 180 degrees, the supplementary, we subtract the 125 that we have for angle A, we can find angle C, and this will be 55. So down here we've got 55 degrees. And then the next property we want to talk about is that this is in the isosceles trapezoid, our base angles are going to be congruent. So now we can come down here and we can say, okay, well, here's a base angle and here's a base angle. Okay, I'm going to go ahead and highlight this. We're looking for angle D. So if these are congruent, we'll go ahead and write in base angles congruent. So angle C is congruent to angle D, making the measure of angle D the exact same, 55. Okay, 55 degrees. All right, so let's take a look at the next one here. We are finding the measurement of angle L. Angle L is going to be right here. We are only going to need to use one property, and that's going to be our regular trapezoid, just all trapezoids. We're going to have that our leg angles are supplementary. So here we'll go ahead and note we're using the property leg angles are supplementary. So we're going to do exactly what we just did on number 3. We're just going to subtract it from 180 and we're done. So here we go, 180 minus 40. A lot of us could probably do that one in our head. Just get 140 degrees. Please make sure that you're rewinding if you need to, okay? Now, on number 5, we're going to have to do 2 different processes because we're going to solve for x and we're going to solve for y. So let's take a look first at solving for x. All right, this is my solving for x section. We're seeing here that PR, so from P to R, right here, is going to be 3x minus 7. Hopefully I don't need that space later. And we're told that, I'm going to go ahead and skip this y real quick. Over here, let's look at TA. TA is the other diagonal. This diagonal is going to be 39. Sorry, this one's 20. My bad. So we're looking at our diagonals with these, and we need to remember that this is an isosceles trapezoid. So because of that isosceles characteristic there, we're going to use the property that the diagonals are congruent. So all that means is we just need to set these two equal to each other. So we have 3x minus 7 equals 20. Go ahead and pause the video and solve for x. I'm just going to pause it, jot it down. The answer is about to pop up real quick, but you should be able to solve for x by now. All right, so we should have come up with 9. Here's the work. Check it and make sure that you did it correctly. Let's take a look at y now. How are we going to solve for y? Well, we're told that PT, so this side over here, okay, is going to be 3y. And we're told that RA over here is going to be 39. Well, in that isosceles trapezoid, our legs are congruent. So here we'll put legs are congruent. So we just set these equal to each other. We have 3y is equal to 39. I don't feel a reason to pause the video because this is a very easy. Just divide both sides, and your y is going to come out to be 13. So these are your bases of your trapezoids, whether it's just a trapezoid or an isosceles trapezoid. The only difference is, well, the isosceles has a lot of new characteristics with those congruent sides. Let's go ahead and take a look at kites now. This is another quadrilateral that we have. Your kite is going to, we're going to have several different characteristics. It's going to have the same characteristics or properties as your quadrilateral. It is a four-sided figure, and its interior angles add to 360. But the kite stands alone over here. It doesn't share many properties other than these two properties. It does not share any other properties with anything else on this flow chart. So let's take a look at the first one here. The first property is telling us that we have two consecutive sides congruent. So first property, what you need to see is we have two shorter sides and two longer sides. Well, the consecutive sides here are going to be congruent. And then these, not all four congruent, that would be, square or rhombus, but here we've got the two shorter sides are congruent and the two longer sides are congruent to each other. Second, we have the diagonals are perpendicular. This is where we need to remember this means 90 degrees. So the second one here, now the diagonals a lot of times, in this case, it's not going to look like they're diagonally, but they are diagonals, and they are perpendicular. Okay? Now another thing I do want to point out before we move on to the next one is you're going to see this a lot, and I know I discussed this in another video with either the square or the rhombus, but here we're going to take a look here that we're going to end up with this right triangle. Okay? This can come in handy. So we're going to end up with a right triangle here. Number 3, we have one pair of opposite angles are congruent. The pair of angles that are congruent are the ones connecting the non-congruent sides. So these two sides are non-congruent. So that angle will be congruent with the opposite angle over here. All right, make sure you know which ones are congruent. And then number 4, we're going to talk about a main diagonal and the cross diagonal. The main diagonal is going to connect the two non-congruent angles. The cross diagonal is going to connect the two congruent ones. So the cross diagonal is going to be bisected right here. So it's going to be that shorter diagonal there. Okay, we're going to split that in half. The main diagonal is going to cut it in half, two congruent parts. A lot of congruencies going on here, right? Number 1, 3, and 4. So let's go ahead and start applying these and seeing which properties we are using. All right, so number 1, we want to find BC. Okay, so we want to find BC, which is going to be right here. So we don't have the measurement of its congruent side over here, but what I just mentioned before on property number 2 up here, our diagonals are going to be perpendicular. So what we're going to wind up with here is this right triangle. If you know your triples, you might already know the answer to this one. So let's draw this triangle to the side. So we don't have all the distractors. Not too bad of a triangle. Here's our right angle. We've got 5 as one of the legs and 12 as the other leg. So we need to find C in Pythagorean theorem. Okay? Here, the property that we're going to use, we're going to go ahead and write in, the diags are perpendicular. Please write out the word perpendicular if you don't know what that symbol means. Okay? So let's go ahead and follow our a squared plus b squared equals c squared. Solve for Pythagorean theorem. We have a and b, our legs. 5 squared plus 12 squared equals c squared. I want you to pause the video now. I want you to solve this on your own. I am going to pause it, and the answer is all of a sudden going to pop up. So please pause it and use your Pythagorean theorem skills. All right, after squaring, adding, and square rooting, we did have a perfect square there. Didn't have a radical. We've got C is going to be 13. All right, so let's take a look at number 6. If HJ, so HJ right here is 7, we want to find the length of HG. HG is right here. Well, very, very simple. We've got our property that consecutive sides are congruent. So what that means is that segment GH is going to be congruent to segment HJ. So both of these will end up being congruent. So GH is just going to be that 7. Okay, real simple, congruent, not even having to solve for anything there. Next one's going to be even easier, as long as we got that property. We want to find the measure of angle JRK. So we're going to go from J to R to K. So we're looking for this angle. Well, that is a straight up property of ours. Look up here, property number 2. Your diagonals are perpendicular, measuring 90 degrees. Not even having to solve for anything. Okay, we've got this 90 degrees. So our property, the diagonals are perpendicular, equal to 90 degrees. So it's just 90. There you go. Nice and simple. All right, so we're going to have a couple different things here that we're going to work with on number 8. If WXYZ is a kite, we want to find the measure of angle Z. So this is the angle we're looking for right here. Now, one thing that we need to remember is that we do have one pair of opposite sides congruent. Okay, so let's kind of start there. If our opposite sides are congruent, all right, that means angle Z and angle X are going to be the same. Well, the problem is that how's that helping me? I don't have angle X. Okay, or sorry, angle X. Yeah, I don't have angle X. So what we can do is we're going to go ahead and we're going to use our property of our quadrilaterals. The sum of the interior angles equals 360 degrees. Okay, so if we add all 4 of these together, set it equal to 360, we've got it. Well, we don't know the numbers for X and Z, so we'll just use a variable, X. So here I've got a total of 2 X's plus this 80 degrees where angle W is, plus the 50 degrees, and it's kind of hard to see, it's 50 degrees, I believe. Oh, I think that is a 60 degrees. All right. We got a 60 degrees. And this is all going to be equal to 360. Okay? Yeah, I think that's 60. We're just going to say it's 60. All right, we're going to combine our like terms, solve for X. Okay? Here I've got 2 different constants, so I have 2X equals 140, oops, sorry, plus 140 degrees. It's kind of sloppy here. All equal to 360. Okay, we're going to subtract that 140 and then divide by the 2. I'll go ahead and not worry about pausing it here. So 2x equals 360 minus 240, sorry, minus 140, it's going to be 220. You divide both sides by that 2, which we should know how to do. And so this angle is going to end up coming out to 110 degrees. All right? So we know that both angles are going to be 180 degrees. So here we can also use the property of one pair of congruent angles. We'll put one pair of opposite angles congruent. So that means that angle X is congruent to angle Z. And so all we've got here is that 110 degrees. All right? So we have to do the sum and then know that those two, so we kind of use those 2 different properties. If you have any questions, please ask your teachers. You can also look up other videos on YouTube if you'd like about properties of trapezoids, isosceles trapezoids, and kites.